Delaware Tech, Chemistry 110, Chemical Quantities and Reactions Continued, Chemical Yield. Well, we've already spent a bit of time going over how to use stoichiometry to calculate how much product you get from a given amount of reactant. And when we're talking about chemical yields, first you need to figure out how much you made in a chemical reaction, and then you compare that to how much you actually expected to get, and you ask yourself, how close was I? Well, the way you calculate how close you were to what you were expected is you determine the theoretical amount that you were supposed to make, and that is right from stoichiometry. You've already been doing plenty of those calculations, and now you compare that to what you actually made, what you actually got in a laboratory experiment. So let's talk about that. So, a couple key terms. Theoretical yield is the maximum or expected amount of product. This is the amount you calculate using stoichiometry. Now, the actual yield is what you really got. So you do your chemical reaction, you expect to get a certain number of grams, but you found that in the end, after you purified your product, you got less than that amount of grams. And you have to ask yourself, okay, maybe not all of it reacted, maybe I lost some in my purification, maybe I didn't purify the right amount and I have too much of my actual yield, more than I expect because some of what I purified is not the right material. Okay, and now you compare those two. So the percent yield is the ratio of the actual amount, what you got in the lab, to the theoretical amount, the amount you calculated using stoichiometry. So you merely divide the actual amount by the theoretical amount, the stoichiometry amount, and then convert it to percent by multiplying it by 100%, and that's your percent yield. It's the same as thinking how much did you make divided by how much you should have made, and then converting that to a percent. So, for example, you made 75 grams of a product, but you calculated that you should have made 88.9 grams. What is your percent yield? Well, you take what you did make divided by what you should have made, and you multiply it by 100%. And that gives us a yield of 84.8%, about 85%. And this is not bad for a lot of chemical reactions. Some chemical reactions go to close to 100% yield, but those are rare. We get some reactions that only make less than 1% sometimes. So it's possible to get all kinds of different values. You typically don't want a value too low because it's not worth making the product if your reaction doesn't work that well, or maybe you did something in your purification and you lost your product in the actual final steps. You might get a yield above 100%, and that would be because you ended up purifying things that weren't your actual product. Maybe you didn't get rid of all the water if you were doing the reaction in an aqueous phase, and maybe it's not completely dry, so some of what you're weighing in your yield, in your actual yield, is not really actual yield. It's water that you just haven't gotten rid of. And you might end up with 110%, which doesn't make sense until you realize that you probably just haven't cleaned up your material enough. So there are plenty of real-life applications. Anytime you're in an industry that uses chemical reactions, yield is always calculated. You always want to know how much material you expected to make versus how much you actually made and purified. And so here's an example where you're using stoichiometry to determine your theoretical yield first, and then I'm giving you the actual yield. So it says 105 grams of chlorine reacted with excess methane, CH4. Okay, so I've given you one of the reactants, chlorine gas, and I've told you the other reactant is in excess. That means we don't have to worry about it. There's plenty of methane around. We're only worried about how much product the chlorine can make. And I say if 10.0 grams of a CHCl3, also known as chloroform, was actually produced, then what is the percent yield? So I'm giving you the amount that you actually produced, 10.0 grams of CHCl3. And this will give you your actual yield directly, but you have to calculate your theoretical yield using stoichiometry. So your theoretical yield, you start with what you have, 105 grams of chlorine that are reacted. You need the molar mass of chlorine gas, Cl2, which is 70.906 grams per mole. Put the grams on the bottom, the moles on the top. I give you the chemical reaction. In this case, it's already balanced, and you see that for every 3 moles of chlorine, you will get 1 mole of CHCl3. And then once you know how many moles of your product, you can turn your moles of product into grams of product if you know the molar mass. And I'm giving you the molar mass of CHCl3 right there, 119.378 grams per mole of that material. So this allows us to calculate the expected amount of product that we should get if all of the chlorine reacted and we had a perfect purification that didn't purify any impurities and captured everything we made without losing anything. That's what we hope under the very best conditions. But we actually got much smaller amount than that. We actually got only 10.0 grams of product instead of this 58.936 grams. So our percent yield is 10.0 grams over 58.936 grams times 100% because this is percent yield. And this gives us a final yield of 16.970%, which we round to 3 significant digits. And that gives us a yield of 17.0%. Not very impressive, but maybe that's good enough. It all depends on the industry. It all depends on the cost of materials. And a low yield in one case may be a high yield in another. You never know until you're working in the actual industry to know whether something is a good yield or a poor yield. But this seems to us as a poor yield, obviously. So here's another example. 50.0 grams of NO react with excess oxygen. If 75.4 grams of NO2 was actually produced, what is the percent yield? So we have 2 nitrogen monoxides react with 1 oxygen to produce 2 nitrogen dioxide molecules. I've already given you the balance equation. You can calculate all 3 molar masses on your own and then determine your theoretical yield. Actually, you only need the molar mass of NO and the molar mass of NO2. You don't need it for oxygen. And determine your theoretical yield using stoichiometry, and then compare that to your actual yield, 75.4 grams, and calculate the yield. And I'll pause here. You can stop it. And let's see how you did. So first you have to calculate the theoretical yield, and that's really the hard part of this problem. So you start with your 50.0 grams of nitrogen monoxide, and that gives you an expected product yield of 76.660 grams of nitrogen dioxide, NO2. That's what you expect. That is the theoretical yield if everything was perfect and your purification was perfect. But you actually got 75.4 grams, a little bit less. This works out to 98.356%, a pretty good yield, 98.4% yield, and in most cases, most chemists would be very happy with such a high yield. And with that, we'll stop here.